In this video, we're going to talk about topic 8, section 1, statistical questions and variables. So in this lesson, we will be able to define and recognize a statistical question, define and identify a type of statistical variable represented by a question or by data, and distinguish between qualities for the purpose of descriptive modeling. And so ultimately, this section and the next section are a turn from what we're used to because it's particularly all vocabulary. And so I might suggest making flashcards or something so that you can remember these terms because there's going to be a lot of them. So for the first item, we're going to talk about statistical questions. So a statistical question is something that can be answered by collecting many pieces of information. And so the key there is many of them. So we're collecting this data and then using that to summarize. So we're doing something to find a value to represent or finding percentages, that kind of thing, to summarize that data. So in the first problem, we're given 2 questions and then 2 data distributions, so 2 graphs, and we're asked to compare whether they can be statistical questions or not, or represent statistical questions. So the first question is, in what month is your birthday? So remember that the key here is it should have many answers. So this question is directed at one person. So that means that this is not a statistical question. And the reason is because there's literally one answer. Whoops. Versus if we change the question a little bit and we say, what month has the most birthdays of students at your school? Now you're asking many people the same question, what month is your birthday? And you're collecting that information. So the statistical question is something that I can collect many of pieces of information or data and summarize. So because this one requires us to collect multiple answers, in order to actually answer the question, we are categorizing that as a statistical question. Next, we have some data distributions, and we're asked the same question. So which one answers a statistical question? And so if we look at the description for the first graph, distance traveled to school, it looks like there's 2 factors. So the horizontal axis is the age of the student, and the vertical axis is the distance that they travel to school. So they're collecting, this is representing 2 pieces of information. So each dot represents a person's age and their distance traveled through school. And so each dot represents a different student as their travel to school. So that would mean that since each dot is a different student, this is statistical. So each point is a different student. And so ultimately, this is a gather and summarize multiple data points. So each point is a different person, ask the same question. I can now find averages between those things. The next graph in B, we have the travel time at 20 miles per hour average speed. So the horizontal axis represents the distance traveled. The vertical axis represents the time in minutes. So this is not a statistical question. Mostly because if I think about the question that's asked, it's if I want to know how far this vehicle or person, whatever it is, it has traveled after a certain amount of minutes, like the answer's set. I multiply the minutes times the speed. And so that means that it's not statistical. Okay, so again, this question, whoops. This question's answer varies predictably because there's only one answer there's only one vehicle, sorry, traveling at a constant speed. Sorry, my handwriting isn't great on this thing. So from here, now that we have defined the idea of a statistical question, so a question that can be answered by collecting many pieces of information, thus our data, and summarizing that data in some way. Now we're going to define different types of variables. So a statistical variable is a quantity or quality that can be measured or counted. Okay, so it's either something that has a value itself, or I can count how many of the same response I get, and for which the data are expected to differ from one observation to another. So the two main types of data is categorical data and quantitative data. And so looking at this, categorical data is data that fall into categories or that indicate a qualitative rather than a quantitative attribute. So ultimately, categorical variables are something that I can describe using words, is a good way to think about categorical. So again, you should be familiar with the terms quantitative versus qualitative, right? And so quantitative variable is numerical data that can be compared, added, subtracted, and otherwise operated on. So all that I can do with categories is count them, versus a quantitative variable, I can add them, multiply them, subtract them, find their average, that kind of thing. And so ultimately, those are the two main categories that we'll talk about in terms of types of variables. So whether we have data that is words or data that is numbers. So in the next example, we're looking at what type of statistical variable is represented by the question and the corresponding chart. So the first question is asking us, what is your favorite summer Olympic sport? And so notice 25% said track and field, 25% said basketball, 20% said swimming, 30% said gymnastics. And so if we think about this, this is a categorical piece of data. And it's really just because, so our answer is limited to types of sports. And types of sports ultimately means it's a word. Okay, so since it's a word, this is categorical data. What is the typical number of apps a teenager has on a smartphone? So a question has the word number in it. So if I think about that, that means that this is going to be a quantitative variable. Because the answer is a value. It is a number, right? They're looking specifically for a number. That's what tells us that something is quantitative. So now moving on to looking at who we're collecting data from, we're gonna next talk about population and sample. So the population of data is the set of all members of a group that you wanna know something about. So if I'm collecting data, the population is the group of people that I wanna generalize about. Okay, so if I'm talking about all teenagers, I could look at a sample or a subset of the population that might be the students at our school, right? So all the students at our school can represent all of the teenagers in probably our country or our state, right? And so the sample is a smaller group than the population, right? So if I'm looking at this in general like that, the population is bigger than the sample. Okay, so thinking about that word of subset, right? So subset means that it is a group within. So a sample is a group within the population that's being studied. So I can't talk to all teenagers in California, but I can talk to the students at Centennial. So in example 3, we're going to be looking at distinguishing between populations and samples. So since I can't talk to the entire population, the sample is the people that I'm actually studying, okay? So just a hint for when you're trying to figure out the difference between the population and the sample is the group that actually participates in the study. Whoops. So in each of these situations, there's going to be a population and a sample. So looking at this, we have a school newspaper that randomly selects 30 students from each grade level to participate in a survey to determine the opinion of students at the school. And so they want us to categorize 3 different groups. They want us to categorize the sophomores that are surveyed, all the students that are surveyed, and the students at the school. So remember that the largest group is the population. So if I think about that, that means that all the students at the school is the population. Right, that's their target, right? They want it to determine the opinions of students at the school. So they're looking for, what does everybody at the school care about? But I don't have time to talk to everybody. So I'm going to select these 30 students from each grade level, and they're going to represent everybody, right? And so the sophomores surveyed are part of the sample. I'm going to add the 30 sophomores surveyed. And then the bigger part of the sample is the 30 students in each grade surveyed. So again, the key there is that they're the ones that are actually surveyed. They're actually participating in the study. So then for B, a polling organization randomly chose eligible voters in the state of Illinois to ask who they would vote for in an upcoming election for governor to determine who will win the election. So what are the sample and the population in this scenario? So the population, if I think about all the people that vote for the governor of Illinois, represents all the registered voters in Illinois. Right, so those are the people that vote for the governor. So when I'm conducting a survey to determine who I think will be the governor, I am predicting what all of the voters in Illinois will vote for. And so then this doesn't really give us a number, but it just says that they randomly chose eligible voters in the state of Illinois to ask. And so really it's just that eligible voters selected to survey. So sometimes it's not a very nice answer or a very concise answer because they don't give us very much of a description besides that they were randomly selected. So whoever that polling organization talked to, that's the sample. They don't tell us a number, they don't tell us anything about that, but those people represent all the people that can vote in that election. So moving on to this, now we're talking about what kinds of questions we can ask, how the answers to that question are categorized, and then we moved on to who we're asking, right? And how we categorize who we ask compared to who we want to actually know information about. And now we're going to talk about bringing those two things together. And so a parameter and a statistic is the information that we collected from our data and analyzed and how that's related to the population and the sample. And so a parameter is a measure that describes a population. So what's nice is parameter starts with a P, population starts with a P. You just need to remember that they go together. The same thing goes with a statistic. So a measure that describes a sample of the population is a statistic. Statistic starts with an S, sample starts with an S. The two words go together. So a statistic describes the sample. The parameter is a number that describes the population. So in example 4, we're identifying whether these things are statistics or parameters. Some of these will have both. So for A high school has 3 lunch periods. In a randomly selected lunch period, 24% of students brought lunch from home. So the question that we're asking is, does this number represent everyone in the population, or does it represent just the people who were studied? So in a randomly selected lunch period, that's not everyone. 24% of students brought their lunch. So since it does not represent everybody, this is a statistic. So the 24% is a statistic. And so as soon as you see those words randomly selected, that means that we are talking about a sample, okay? And so that means is that this represents that this number is a statistic. Okay, so when you see those words randomly selected, we're discussing a sample. At the end of its first year of business, a movie theater collected data on how well its concession stand operated that year. The theater used its total yearly concession sales and number of tickets sold to calculate the mean amount spent at concessions by a moviegoer was $8.14. So this word that you see total is different than randomly selected, right? So if I see something that looks like total or whole, that tells us that the number $8.14 is a parameter. Okay, so in the last one, we're asked to identify both the parameter and the statistic. So they're telling us information about the sample and about the population, and we have to discern which one is which. So a snack company produces bags of cashews so that each bag contains about the same number of cashews. The bags are filled with an average of 31 cashews. Carter gave each of his friends a bag of cashews for a snack after school. There are 10 bags contained an average of 28 cashews each. Identify the parameter and the statistic. So remember that the parameter is the one that represents everything. And so the one that represents everything is the average that's coming from the snack company. So 31 is the parameter because it represents the whole manufacturing. And then the statistic is the one that just represents those 10 bags. So 28 is the statistic, again, because it was only their sample of 10 bags. So the work from this section is going to be similar, where you're looking at scenarios, vocab data, and you're identifying which of these different vocabulary words it fits under. And so again, I suggest making flashcards, doing something so that you can remember the words, because ultimately just understanding them and knowing them is how you're going to be able to be successful for this section.